Today, we'll be talking about the trig substitutions. In particular, I will give you guys 4 examples on how to use the sine substitution. Of course, there are also the tangent and secant substitutions. So the first question is, when do we use the sine? Well, the answer for that is when we see a squared, where a is just a constant, minus x squared, and if this right here is inside of the square root, then it's usually a good idea to let x is equal to a times sine theta. And as a little note right here, 1 minus sine squared theta is equal to cosine squared theta. And I also want to tell you guys that you could have done this as x is equal to a times cosine theta as well. But when you differentiate that, the derivative cosine will give you negative sine, and nobody likes the negative. So that's why we will just use the sine for this. Take a look at the first one. We have the integral of 1 over square root of a squared minus x squared. So as we can see, we have this right here. And you see, we do not have x on the top because otherwise we can just do a u sub for that, but we don't. So let's just go ahead and do this and see what happens. So I'm just going to let x equal a times sine theta, as we said it over there, and then we just have to do our usual business. And the usual business is that we differentiate both sides, so we get dx, and that's going to give us a, and the derivative of sine is cosine, and then we have the theta d theta. So we can just now take this integral to the theta world, and we are looking at the integral of 1 over square root, and here we have the a squared, but this x right here is what we said to be a times sine theta, so we're just going to write that down, a times sine theta, and then we have to square that. And we see we have the dx right here, which is all that. So just be sure that you multiply this right here as well. A times cosine theta d theta. Do not miss the d theta. That's extremely important. I will point out why later. So this is what we have now. And now we can simplify this a little bit. Here we have a squared, and we also have x squared right here. So we can factor that out. A squared, and then we will just have 1 minus. Here we have sine square theta. Well, this right here is what I told you. We'll be expecting to use this identity, so we can replace that with cosine square theta. So this is just a squared times cosine square theta. And you have to keep in mind, this right here is still inside of the square root right here, right? And the beauty of this is that this cancels out. So altogether, we just get a times cosine theta. And you don't have to worry about the absolute value for this indefinite integral because we're just trying to find an antiderivative for this. Alright, and now here's the best part. A here, and then we have a on the bottom, so we can cancel them out. Likewise, cosine, cosine, cancel each other out. So we actually just have to integrate 1. But the answer for this is not just x, because we are in the theta world. So really be sure to write down d whatever every single time. Integrating 1 in the theta world, we actually get theta, but we still have to go back to the x world, and to do so, we just have to look back here. We know x is equal to a times sine theta. This means we can divide a on both sides, so sine theta is equal to x over a, and right here we can just say theta is equal to the inverse sine of x over a. So ladies and gentlemen, this right here is just the theta, which is pretty much the answer for that. So I'm just going to write that down right here for you guys. Final answer, inverse sine of x over a, and then we are all done. So I'll just put down a plus e right here and box the answer. Just like that. For number 2, we have the integral of square root of 2 minus x squared over x squared. Here we have this number 2. And we really have to look at that number as a number to the second power. So the truth is, for the 2, we'll just purposely look at this as square root of 2 and then square. So this tells us the a is square root of 2. So here you see we have that. So we can just go ahead and say x equal square root of 2 times sine theta. And then just continue. The usual business, differentiate that, and then we just get square root of 2 times cosine theta d theta, and of course take this integral to the theta world. So we are looking at this as the square. I'm going to actually leave some space right here. I almost forgot about that. Leave some space. Because we have the square root on the top, and I'm going to simplify the square root expression, so let me leave some space right here. Anyway, here we have 2 minus, take a look right here, this x is what we said to be square root of 2 times sine theta, and then we have to square that. And you can see if this is to the third power, you will know that it's not going to work out. So just like, it's so nice the second power, right? Alright, and then on the bottom here, we have the x squared, and the x is going to be that square root of 2 times sine theta, and then we square it. And don't forget that dx is all that, so we multiply by square root of 2 times cosine theta d theta. Wow, I know, it's quite a lot, but don't worry, just kind of relax, and then we can finish this. Okay, to do so, here we see 2 minus, and this is just a 2, right? Because square root of 2 squared is just a 2. So we can factor that out. And then we get 1 minus, this is sine square theta. And this right here is again cosine square theta. And then we have the 2 in front, like this. And remember, this is still inside of the square root, like this. And the square root of 2 will just leave it as how it is. So we have square root of 2, and this right here, they cancel, so we just have cosine theta. So that's for that. And if you look at the bottom, here we have square root of 2 squared, which is just a 2. And then this right here is sine square theta. Alright? So this is what we have. Check this out. Square root of 2 times square root of 2 is a 2. That's on the top. But here we have another 2. So they actually all cancel each other out. Alright? And then if you look at this times that is cosine square theta. I'm going to write that down to make it super clear. On the top we have cosine square theta. On the bottom we have sine square theta. And then d theta. And of course you can recognize this as cotangent square theta, and then you can use the identity to break it apart. But I would just like to prove that little identity for you guys real quick. Cosine square theta is the same as 1 minus sine square theta. So this is what we get. First, we do 1 over that, and that will give us cosecant square theta. 1 over sine is cosecant, but this is the square, so we have the square. Next, this over that is just 1, right? So very nice. So we have that minus 1. Again, we are in the theta world like this. Now, what's the integral of cosecant square theta? Well, the answer for that is negative cotangent theta. And then minus 1 in the theta world, integrate that, we get theta right there. Okay, now we just have to go back to the x world, and this is how. Refer back to our substitution right here. I'll put this down right here. We know x is equal to square root of 2 times sine theta. We can just divide the square root of 2 on both sides. So we get sine theta is equal to x over square root of 2. Again, we are looking for the theta here. So theta is just going to be the inverse sine of x over square root of 2. So that's okay. Well, how do we get cotangent? This is how. So if you look at this right here, we can construct a right triangle. And I would recommend you guys to always put a right angle right here and the angle theta right here, just to be consistent. Because this way you can see x is the opposite, which is right here. And then this right here will be the hypotenuse because we are talking about sine. So square root of 2 will go right here. And now we just have to figure out the adjacent, and that's going to be, you open the square root, you do this thing square, so square root of 2 square, and then minus this square. And now look at this triangle, we can just do the cotangent. So have a look. Here we have negative, and for the cotangent is the adjacent over the opposite, right? It's the reciprocal of tangent. So we do this over that, so we have this, which is square root of 2 minus x squared and then over x. So that's what we have. And then minus theta is this. So we are done after we put down the inverse sign of x over square root of 2. Alright? So of course, don't forget the plus c, this right here. You see it. For number 3, we have the integral of square root of 1 minus 4x squared. Because we have this 4 right here, so this is what we do. We are going to rewrite this integral as the square root of 1 minus, open the parentheses, make that to the second power. Originally here we have a 4. Inside here, we will put a 2 because 2 squared gives us the 4. And likewise, put down the x right here. And of course, we still have the dx. So right here, some people might tell you to do u sub, let u equal this, and then continue the usual business. But I will tell you, you see this right here? It will be the new x squared part right here. And it's just going to be that we are going to let this, the 2x, equal a times sine theta. That's all. And notice that a is equal to 1. So I'm going to just do it that way. I think it's pretty clear. So right here, I'm going to put this right here, which is the 2x, make that equal sine theta. Again, our a is equal to 1. Once we have this, we can divide the 2 on both sides before we differentiate. So x is equal to 1/2 sine theta, and then dx is equal to 1/2 cosine theta d theta. So now we can take this integral to the theta world. And we will get the integral, and then we have the square root. 1 is 1 minus parentheses, the parentheses. And now we see inside here we have 2x, and that's exactly what we said to be the sine theta. So I can just replace that right here. And then we have to square that, and then the dx is all that. So multiply by 1/2 cosine theta d theta. Okay, now we have to simplify this. 1 minus sine squared theta is just cosine squared theta. And then we have to take the square root for that. But again, this and that will cancel. So we just have cosine to the first power. And we have to multiply by another cosine to the first power. So that's cosine to the second power. Here we have 1 over 2. Let's put that in the front of the integral. And then we're looking at the integral. Cosine x, well, cosine theta times cosine theta, as we said, that's cosine squared theta. And then we are in the theta world like this. Well, how do we integrate cosine squared theta? We will have to use the identity, right? We don't want to have cosine to the second power. We want to have cosine to the first power. All right, this is the identity that we are going to use. I'm going to first write down the 1/2 in the front. So this right here doesn't change from here. However, the identity for cosine squared theta is 1/2, and then we multiply by 1 plus cosine of 2 theta. So the blue part is for that. So that's why we have another 1/2. And then we still have to integrate that. And then this is still in the theta world. Okay. Now, this times that is of course 1 over 4. And then I'm going to open the parentheses for the result of integration. 1 in the theta world will give us theta. And then integrating cosine, we get positive sine. And then the input stays the same, which is 2 theta. And again, because the derivative of 2 theta is just a 2, so we can do this. And of course, don't forget that we will have to divide it by the derivative of 2 theta, which is 2. I'm going to be putting down 1/2 right here. And then we can just put down a plus right here. Because the integral of cosine is positive sine, so that's why it stays positive. So just like that. All right, I know this is a lot of work, but we're not done yet. We're almost done. All right. Again, we will have to go back to the x world. But the problem here is that here is sine 2 theta. Our original substitution only deal with theta inside. So we will have to do the double angle identity for sine. This part right here is the same as 2 times sine theta and cosine theta. And you see here we have the 1/2, because from here, 1/2 times this 2, well, they cancel each other out. So I'm going to write down what we have right here for you guys. 1/4 times theta, so that's 1/4 theta. Next, 1/4 times this, which is just plus 1/4 sine theta cosine theta. So that's what we have. So that kind of clears up the constant multiples, and I think we're okay now. And the final step is go back to the x world as we said it earlier. Well, let's see. We are going to look at this right here. Look at this. We know we have sine theta being equal to 2x. This time though, I'm going to purposely look at this as 2x over 1 because we are going to construct a right triangle, put the right angle here and then the angle theta here. Sine is opposite over hypotenuse. So now we are going to figure out the adjacent, which is square root this thing square. So be sure you do the hypotenuse square first, and then minus this thing square. So we'll have the 2x and then square. So this is pretty much all we need. Let's go ahead and figure this out. So here we see that we have 1/4. Theta is just going to be the inverse of 2x, right? So we can just put that down. We have the inverse sine of 2x. So that's the first part. Next, we have plus 1/4 from here. And then sine theta is the 2x, right? Sine theta is just the 2x. So we can put that down right here. Next, we have cosine theta. Well, for cosine theta here, we can look at this triangle, and cosine is adjacent over hypotenuse, which is just this square root part. And that's going to be square root of 1 minus 2 squared and then x squared, right? So it's just 4x squared. And of course, you can kind of expect that the original square root part, appears again. So that looks pretty good. Yep. So that's pretty much it. But of course, the final touch is that I'm going to reduce this a little bit. So yeah, that's pretty much it. And perhaps I am just going to erase this triangle. I don't know. Because you see, this is the problem. Sometimes you just write down the same thing over and over again. If you leave this on the test, my students, I will be totally cool with that. Right? You don't have to copy down the same thing over again. But I'm making a video, so I'm going to write this down one more time. 1/4 inverse sine of 2x, and then plus 1/2 x square root of 1 minus 4x squared. And then we are all done. So here will be the answer for that. Okay, I accidentally erased the notes right here. But it's okay, this is number 4 already. Here we have to integrate 1/x times the square root of 9 minus x squared. So focus on inside of the square root. This is the 9. Well, that means a is equal to 3. So let me just write that down real quick. 9 equals 3 squared. Alright, so we are going to let x equal 3 times sine theta, and then do the usual business. Dx is just going to be 3 cosine theta d theta. And again, take this integral to the theta world. We are looking at the integral of 1/. Here we have this x right here, which is 3 sine theta, so we have to put that down. And then we have the square root 9 minus, oops, didn't write it well. Here we have x squared, x is that, so write down 3 sine theta, and then we will have to square this. Yeah, I know, another big expression. But don't forget, for the dx, we also have to put down this right here, and that's 3 cosine theta d theta. Wow, I know. Okay, simplify this part right here real quick. This is 9, this is also 9, so we can factor out the 9 and then multiply by 1 minus sine square theta. This right here is just cosine square theta, and we have the 9 in front. Again, these two things, right, they are still in the square root. This will give us just the 3, and then cancel out the square root, so we have cosine to the first power theta. So that's what we have. Okay, notice that this right here is on the bottom, and this right here is on the top. So we can actually cancel, cancel, and likewise cancel, cancel. Pretty good? Pretty good, I would say. So what exactly are we integrating? Well, this right here is just going to be 1/3, and then we have the sine theta on the bottom. And I'm just going to write it down right here, 1/3 integral. Because we just have 1 over sine theta, they are gone. 1 over sine is cosecant. So let's put that down right here. Okay, how do we integrate cosecant theta? This is a standard result, so you have to remember that. Here's the deal. This right here is equal to negative ln absolute value of cosecant theta plus cotangent theta. And of course, we still have the 1/3 right here. And I want to make this clear. If you look at like some textbooks, or maybe if you look at some notes online, some people might say the integral of cosecant theta is ln absolute value of cosecant theta minus cotangent theta. They have the minus instead of right here, they have it here. In fact, they are equivalent identities. So this one, or if you have the negative right here, they are okay. But I have a video going from here to here, so you guys can check that out. Okay, so now the usual business is just that we have to go back to the x world, and then we'll be done. Look at this right here real quick. We know that x is equal to 3 sine theta. This means sine theta equals divided 3 on both sides. So we're looking at this. Draw a right triangle real quick. Put the right angle here and the angle theta here. The opposite over hypotenuse. And then to figure out the adjacent, we open the square root, and then we do this thing square minus this thing square. So this is the triangle that we have. And now we can just pretty much finish this. We have negative 1 over 3 ln absolute value. Cosecant theta, well, cosecant is just what? Hypotenuse over opposite. So we have 3 over x. It's quite strange, but that's just how it is. This over that. Next, we are going to add cotangent, which is this over that, right? And this right here is just square root of 9 minus x squared and then over x. So that's pretty much it. Of course, you can also combine the x together and things like that, but I will just leave the answer like this. So put on the plus c. This right here is it. Again, you might see people just have the negative right here instead of on the outside. Again, same thing, all right? So hopefully this video helps. If you guys need more help, you guys know what to do. Check out my other videos and also subscribe to the channels for future videos. And as always, that's it.